the values, they're on the slides here, but I can update them later on. The values are SUID is going to have a value of 4. The set GID is going to have a value of 2, and the sticky bit is going to have a value of 1. So how do we set these if we already have 755, 644, right? Those all 3 columns are taken. Well, we can always go ahead and let's take a look here. Let's go back to our home directory and look at our files. Let's go into perms. And let's say that I wanted to set the sticky bit for that or the regular file, right? So I do chmod. Now, again, the sticky bit has a value of 1, so we do a 1644. Okay, so we append the number to the beginning of our permissions, and that's going to set up for us that sticky bit. But now look at this. That's a capital T. Up until this point, we've seen it as lowercase t or lowercase s. And there's a slight difference here. I want to highlight that just in case you see that on a system, you're like, well, what's going on? I've only seen lowercase t. Now you've seen both of them. Now, the uppercase T means that there is no underlying execute bit. Okay, because it uses the execute bit column, we need to have a way to denote whether that execute bit is there or not. So, for example, if I did a chmod and I said other plus execute for a regular file, now we'll see a lowercase t. Okay, reversing that, chmod, we say other minus x, regular file. We see here now we have capital uppercase T. Same thing goes for the set UID and the set GID bits. Real quick, we'll show that here. Again, we can do a chmod, and let's do a 4644, okay? And a regular file. Again, 4 being for a set UID bit, okay? Notice here I have capital S because we did not have underlying execute bit. I did add that, so I do a chmod u plus x here, regular file. We'll see that it comes to a lowercase s, okay? So just in case you see that on a system, you know either execute bit is there underneath or not, okay? And let's see here. All right. Yep, so this one is just highlighting the uppercase versus lowercase. And this one is a little interesting as well. So chmod with a capital X. You can ignore that dash. That could be a dash or a plus, depends on what operation you're trying to do, but chmod with capital X. So when we use a capital X, that denotes that the system should only add the execute bit if it's already there on another set of permissions. So let's say, for example, you wanted to add the execute bit to all users. Well, it will only do that with a capital X if it's there for maybe the owner or the group permissions. This is one of those things that's really highlighted much better when we talk about it on the command line. So jumping back to our examples here. Let's go ahead and kind of reset some of these files here. I'm going to do a chmod 755 regular file. And actually, because it's a regular file, it should actually be chmod 644. Okay, and we'll get to why that is here in just a little bit as well. So 644, read and write for the owner, read for everybody else, and read for everybody else, right? If it's just a regular file, there's no need to execute anything on it. Now, let's say I want to do a chmod. Let's do a other plus capital X, okay? Regular file. Now remember, the capital X says, oh, add the execute bit if only if there are execute bits on any other part of the file. So if I do a chmod plus X or plus X, L, we'll see that it did not add anything, because there's no other execute bit on this line here. Okay. So for example, let's say if I did a chmod and we'll say user plus X regular file. So lowercase x will add the execute bit there. Okay. So now revisiting our first command, right, with a capital X, executing it again. This time we do see that it added it again because it was already on another permission there, right? So this could be useful if you had a small mistake and you set permissions to a directory or to files incorrectly, and you want to go through and you need to add execute bits to all the directories. Well, you could do that without worrying about adding execute bits to those files, right? Now I want to talk a little bit about why you need execute bits on directories. So let's say, for example, I maybe did let's see here. Let's make a good example for this. Let's put a vagrant here. Actually, we can do this here. Let's do this. This is our home directory here. We have txlf as a user with just read, write, execute for the owner. No permissions for anybody else. We have vagrant here, again, similarly, with read, write, execute for the owner, but nobody else. So if I was su-vagrant, right, and I try to go to home txlf, I can't do that, permission denied, okay? But if you look up here, I have execute bit for all other on txlf2. So cd home txlf2. Okay. In order to traverse a directory or go from directory to directory, I need to have execute bit on there, right? So so any user to be able to go to a different directory, the execute bit needs to be there for all others, right? So that's how we get into the directory. We're executing a command to get into the directory. Okay. So I'm trying to highlight there a little bit.